So we are trying to solve 3 by 3 systems. What this 3 by 3 means is you have 3 variables and therefore 3 equations. So if you're going to solve for 3 variables, you must have 3 equations, one for each variable. Which is why when we solve for just x, we have one equation. When we solve for x and y, like we just did on 1.9, you have 2 equations. And now we want x, y, and z, so we need 3 equations. Each equation is sort of responsible for helping you find a variable. We are going to not number. It used to be number, and I changed it to letter, but I forgot to change this word. A, B, and C, the equations. So your top equation is going to be A, B, C. That way you know which one we're referring to. So when I say equation A, you know which one is A. When I say equation B, you know which one is B. It just helps a little bit. And once you find one variable, you have to plug it back in to find the others. Multiple. Since there's 3, you'll find the first one, you need to find that, plug that back in to find the second one, and plug both of those back in to find the third one. Our first example is going to just be this last step of plugging it back in. It's not going to be actually solving a system. Then we'll get into solving a system on the back side. So these first 2 over here are pretty simple. I'm not going to go through the steps right now. It says use elimination 3 times, and there's a step 1, 2, and 3. We'll get there. I'm not going to explain it right now because it won't make any sense. What do you notice about equation C? It doesn't have a y or x. It already tells us that z is 3. So if you ever see that, that's your sign that one step's been done for you. All you have to do is take that z and plug it back in right here. So then we end up with 3y minus 3 equals 3. A lot of 3's. Be careful with that. Some people think it's 0 because they see this 3 and negative 3, but we have to add that 3 to the other side to get rid of it. And that makes 6. And if 3y equals 6, then y equals 2. There are going to be a couple of spaces where I kind of show you how you can do it in a little bit less steps. I don't care if you write the plus 3 on both sides. If you go from 3y minus 3 equals 3 to 3y equals 6, I'm going to follow you. Okay, that'll make sense. Okay. Then, now we know what y is. I have to plug y and z back into the stop one. Instead of writing every little bit out, what I'm going to do is I'm going to write 2x, and then instead of writing negative 5 times 2, because that's what y is, I'm just going to skip straight to negative 10. I know it sounds insignificant, but saving yourself that one tiny step makes a big difference later. And then z is 3, so 3z would be 9. Maybe I got that wrong. And then negative 10 plus 9. They're already on the same side, so you're just adding those together. That makes negative 1. How do I get it to the other side? Add it. So instead of rewriting the entire equation a couple of times, we're just trying to save a little bit of work. Okay, so I'm going to go over this one more time because we did something kind of confusing. This made negative 1. We don't want that negative 1, so we added it to get rid of it over to here. And then we divide by 2, and x equals 4. How we are going to write our answers for this one is as what we would call a ordered triple. We've seen ordered pairs before, x comma y. That's called an ordered pair because there's a pair, 2, of numbers.
X comma y.
Yep, x, y, z is what we want. So that would be 4, 2, 3. Some people actually find it easier to order x, y, and z. Since there's 3 things, you have to pay a little bit more attention. When there's only 2 things, it's easy to get them flip-flops. And that is how you solve it when you already know what one of the variables is. Okay, it does get a little bit harder from here because, like on number 2, it doesn't always give you what z is. What we are going to try and do on the back side is create this, where you have two equations that just have y and z. But it could be x and z or x and y, as long as it's only two variables. So what we need to do is eliminate between these two so that we can figure out what either y or z are, and then we can plug it back in and find the other one. You have two options. I'm just going to go ahead and blur out what the two of them are, and then we'll pick one. Multiply this by -3, because then that cancels out the 3. Or multiply this one by 2 to make this -4 to cancel out the 4. Which one would you guys rather do? By what? -2? Okay. We're going to take this one and multiply it by 2. We already do have the negative, so we don't need it again, so we don't need to multiply by another one. The top one is going to stay the same. I'm not multiplying by anything. The bottom one is going to double. 2 times 3y is 6y. 2 times -2z is -4z. And 2 times -9 is -18.
Why would you multiply by a number?
Because we want it to be negative, so that these are opposites. Because if you look in the middle of mine right now, these are about to cancel out. And we want that to happen, so we didn't need to multiply it by a negative since they already had that negative there. That's a good question. It's a great question. And then we're going to add them together. 1y plus 6y is 7y. The z's canceled, that's the whole point. 25 minus 18 is 7. And if 7y equals 7, then y would have to be 1. And that is all of the work it took just to find the first variable. These do take longer, that's why there's only 6 questions on your homework. Okay. I do need to plug that back in to one of these equations. I'm going to pick the top one because I always pick the top one. Y plus 4z is just going to turn into 1 plus 4z. So we're just replacing the y with the value.
So it doesn't matter which equation.
Nope. People pick equations for the silliest of reasons too. Sometimes they just avoid the negatives. Sometimes they pick the one without a 7 because they don't like the number 7. I don't know. There's a lot of reasons why you can pick one. It doesn't really matter. I'm going to subtract that 1. 4z equals 24, which means you divide by 4 and z equals 6. And now we know what z and y are, so now we can use the top one. We can't use this top one until we know 2 of the 3 variables. So I'm going to keep the 3x and then plus y, which is 1, minus 2z. I'm not going to write minus 2 times 6. I'm just going to do it really quick in my head. -2 times 6 is -12 equals -17. I am going to write it up there in case some people are just a little, if that's doing too many steps at once for you, you can write it up there if you want. And then we're just solving it. Right now, these two in the middle add up to -11. So to get rid of that -11, I'm going to add it to the other side. -17 plus 11 is -6. Divided by 3 would be -2. And then we just put them in order, x, y, z. The first 4 problems on your homework assignment are like that. 5 through 7 are more like the back side. Make sure before I say this. So let's say you don't have ones that are like this, and you have all three equations with all three variables. You need to pick one variable that you can eliminate twice using these two equations and these two equations. So A and B, and then B and C. You have to use two separate equations. It could technically be A and B and A and C if you wanted to. It just has to be a different pair of numbers, so it's usually just easier to use the first two and then the last two. This is our first step. We have to decide which variable eliminates nicely across all three equations. For instance, I would not pick Z because 3, 2, and 4 would all have to get multiplied by something to cancel each other out. Like 4 and 2 would be fine together, but 2 and 3 wouldn't, and neither would 4 and 3. 4 and 2 would be fine, but 5 and 2 wouldn't, and neither would 5 and 4. So we get one pair, but we need to find another pair that also works. The X's are really nice because this one doesn't have a number in front, so it can go nicely with anything. Doesn't matter what the other two are. So I'm going to multiply B by -3. Does anybody see why? Take a look at it for a second.
I'm taking a look.
It takes a minute to see it. Why in the world would I pick -3 to eliminate the X's?
Because it cancels out the top X and for the other X will be easier to solve.
Yeah. So it cancels out the top X. Guess what? I can do something completely different to cancel out the bottom one. I don't have to use the same version of B. I'm going to go ahead and multiply it. Just know I'm multiplying every number by -3. Then I'm going to write equation A on top exactly the same way as it is. So my goal is to eliminate a variable between equation A and equation B. And that variable I have chosen is X, because now those cancel. Then I just add them together. Those cancel. 10y minus 3z. Careful with your z's, I know they're annoying to write. Equals -27. And I'm going to label this as equation D. Because now I have one equation without an X. I need another one though. And I can't use the same two equations to get there. So instead, I'm going to take B and I'm going to multiply it by something else so that it crosses out the X's here. What do I need this X to turn into to cancel out 2X? -2. So I'm going to multiply it by -2. And I'm going to add it to C. So I'm purposefully using the fact that C is down at the bottom so I don't have to rewrite it again. You can if you want to. And I'm going to add these two together so that these cancel. Because then I can use my new equation from here and my equation from here to cancel out y or z. So we have to use elimination 3 times. The B. Sorry, I didn't draw a very good arrow. So I used A and B to get one equation, D. I used B and C to get one equation. I'm going to call that E. Now I need to put D and E together to do my elimination the third time. That's why I said it takes 3 eliminations to get there. You eliminate the X's here and here so that you have 2 of them ready to go without x's. And now we're going to try and eliminate y or z. Take a look at both of the equations. Here's the y's, here's the z's. Which one is easier to eliminate? Yeah. Y. Y. What's wrong with z? Yeah, they don't go into each other. 3 and 8 are not friendly numbers that go into each other. So all I have to do is make this turn my y into negative 10y. What do I need to multiply by in order to make that happen? Close. Positive 10, because it already has the negative. Multiplying by 10 is actually pretty easy. You just add a 0 at the end of it. And don't completely freak out on me. I know that this looks a little crazy for a second. We're not used to seeing 80 and 110 inside of our problems. It'll get there, I promise. And we add these together. And that gives us negative 83z equals 83. Thank goodness, because there's not a lot of other numbers that 83 goes into. And then we can divide by 83 on both sides. And z is negative 1. You eliminate x between these two, then between these two, and then you put your 2 new equations together. Now, the other reason why we labeled D and E is because we have to plug Z back into E or D. I'm not ready to plug it back into any of my originals because I only know 1 variable, and all of them have 3. I'm going to plug it back into this one since there's no number really in front of Y. So I'm just going to plug in that negative 1. I'm actually going to write it out this time since I've got a lot of negatives. That turns this into a negative y plus 8 equals 11. Then I subtract the 11 to the other side. Negative y equals 3, so y equals negative 3. And we find x as our very last piece. Take a look at A, B, and C. Which one do you think is going to be easiest to find x? Some people see it, some people don't. Yeah, B, because there's no number in front of it. So you just have to do x, and then minus 2y. Again, there's a lot of negatives, so I'm just going to go ahead and write it out all the way. Plus 2z equals 10. And it might even help to label which one you're plugging it back into, so that when you look back at your own work, you're not completely confused as to where in the world you got these crazy numbers. This turns into positive 6, negative 2. 6 minus 2 is 4. And then you subtract that 6 to or the 4 to the other side and get 6. That is probably the most complicated they can get. It doesn't get more complicated than that, so if that one was about all you can take, that's where it ends. Number 4 is actually a little bit easier. Take a look at the numbers in front of the x's, then the numbers in front of the y's, then the numbers in front of the z's, and see if you can figure out why it's going to be a little bit easier than number 3. I'll give you a hint. We're going to eliminate z. Why is z so easy to eliminate? They're all 2. In fact, 2 of them are positive 2, and one of them is -2. So what we're going to do is not multiply it all. We're just going to add together A and C because it's already +2 and -2. It doesn't have to be A and B every time. And you don't have to write this all out if you don't want to either. Just realize that if you don't, you are risking making a small sign error somewhere. So I'm adding together A and C this time. Which just means that next time I have to pick something besides A and C for the other one. That gives me 8x plus y equals 21. Then I do the same thing, but I either have to pick AB or BC. Since B and C are the other two that have opposite signs, I'm just going to add them together as is. That gives me 5x plus 4y equals 30. I'm going to put a little box around the side just so you can see I'm adding those two together. This would be equation D. This would be equation E, technically. I'm not super big on the labeling, just easier to refer to. Now, is it easier to eliminate my x's or my y's? The y's. I need this to turn into -4y. So I'm going to multiply that whole equation by -4. It does need the negative because it doesn't already happen. And then we add them together. -27x equals -54. 27 does go into 54 twice. So x equals 2. Now that we know that x equals 2, this would turn into 16 plus y equals 21. Subtract that 16 over to the other side. Y equals 5. And plug those two back into any of the other equations. A lot of people will pick the top one because it has smaller numbers. 5x is going to turn into 10 minus 2 times 5 is 10 plus 2z equals 4. I'm plugging into equation A. That's actually 0. So z has to be 2. 2, 5, 2.